Hey everybody, and welcome to another physics video. In this video we are going to focus on two-dimension elastic collisions. Let's go ahead and start by reading the problem. Two objects slide over a frictionless horizontal surface. The first object's mass of 2.0 kilograms is propelled with initial velocity of 3.7 meters per second east toward a second stationary 1.1 kilogram object. Both velocities are directed at 20 degrees on either side of the original line of motion. What are the final speeds of the two objects? Let's get started. Let's identify what we do know. Mass 1 is 2.0 kilograms. V1I is 3.7 meters per second east. Mass 2 is going to be 1.1 kilogram. V2I is going to be 0 meters per second because it's stationary. And then since we don't know V1F or V2F, we're going to leave a question mark. We're also going to draw a diagram. M1 is going to be going to the east here, and it will collide into M2. After the collision, both objects move in the diagonal direction with an angle of 20 degrees to the horizontal. This collision still follows the conservation of momentum. However, to approach this problem, we'll have to address the x and y directions separately. Let's start with the x direction. So, to make some changes here, the beginning still stays the same before the collision. M1 times V1I plus M2 times V2I equals to M1 times V1F. And to strictly talk about the x direction, we're going to have to put cosine. Cosine theta 1 plus M2 V2F times cosine theta 2. We're using cosine theta because we're focusing only on the x direction. So here we have our conservation of momentum equation in the x direction, and so we can go ahead and plug in our values. We have 2.0 times 3.7 plus 1.1 times 0 equals to 2.0 times V1F cosine 20 degrees plus 1.1 V2F cosine 20 degrees. We can simplify the values. Right. On the left side of the equal sign here, we get 7.4. And then it will be 7.4 equals 1.88 V1F plus 1.03 V2F. And you notice here that we have two unknowns, so we'll have to come back to this later. For the y direction, you notice from our diagram that neither object moves in the y direction before the crash or before the collision. But after the collision, both objects do move in the y direction. So before the collision, we can say that 2.0 kilograms times 0 plus 1.1 times 0. And the reason it's 0 before the collision is because neither object moves in the y direction. And this all equals to 2 V1F times sine of 20 plus 1.1 V2F sine of 20. And again, the difference this time is since we're focusing in the y direction, we're going to use sine of theta to emphasize that. If we simplify everything, on the left side, we're going to have 0 equals 0.34 V1F minus 0.37 V2F. You might notice where I got that negative sign from. It's because the second object, M2, is going in the downward direction. Same thing as before, you'll also notice we still have two unknowns. So now we are in a situation where you have two equations, one for the x direction and one for the y direction, but they both have the two same unknown variables, V1F and V2F. We're going to have to use substitution method because this is a system of equations that we're looking at. let's go ahead and choose one of the equations to use substitution method. I'm going to use this one right here, 0 equals 0.34 v1f minus 0.37 v2f. And I am going to go ahead and isolate one of the variables. I think for this one, I'm going to choose to isolate v2f. Though it is, if you choose to isolate v1f, you should still be able to get the correct answer. After working that out, we're going to have v2f equals to 0.91 v1f. And after we solve that, we can plug that expression into the other equation. All right, so plugging in back in, we have 7.4 equals 1.88 v1f plus 1.03 times 0.91 v1f. The rest just becomes algebra. So from here, we have v1f as a single variable, and then we can solve v1f to be 2.63 meters per second. Once you solve for the final velocity of the first object, we can take that value and plug it into the earlier equation for v2f, and we can find out that the final velocity of the second object is 2.39 meters per second. This concludes our example on 2D elastic collisions. I hope you found it helpful, and thank you for watching.